Good morning, dear students. Today we are discussing the addressing modes of 8086 microprocessor. Before we learning the addressing modes of 8086, first we know the basic instruction format of 8086 microprocessor. The basic 8086 instruction format, the basic in 8086 instruction format consists of two parts. One is opcode and another one is operand. The opcode is an operation code. It is a 6-bit Unicode code. It specifies the type of operation is performed by the CPU. Opcode is an operation code. It is a 6-bit Unicode code. It performs, it specifies the type of operation performed by the microprocessor. This is the opcode. Next one, operand. Operand is a data contains, it contains opcode. Operand contains data contains. Opcode is performed by a particular operation. That operation required data is provided by the operand. Operand is provided data. Okay. This is the basic instruction format of 8086 microprocessor. Next, we go for addressing. First, we have to know the definition of addressing. The way of representing the data in an instruction is called addressing modes. This is the basic definition of addressing modes. Another definition, the way in which the operands are specified. In which the operands are specified in an instruction is called addressing modes. Next one, the operand is further divided into two parts. One is source and another one is destination. In the instruction format of 8086 microprocessor basically consists of two parts. One is opcode, another one is operand. The operand can further divided into two parts: source operand and destination operand. In that, for example, move destination comma source. Example of instruction, move ax comma bx. Okay, this is the basic instruction format of 8086 microprocessor. The addressing modes of 8086 microprocessor, the classification of a addressing modes is: first one, immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, indexed addressing mode, register relative addressing mode, base index addressing mode, relative base index addressing mode, in inter segment addressing mode, intra segment addressing modes. Okay, these are the classifications of addressing modes in 8086 microprocessor. Next, we go for first one, immediate addressing. Addressing modes means the data will be specified directly in the source operand. Is called immediate addressing mode. The data will be specified directly in the source operand. Is called immediate addressing mode. In that source operand, we can specify either 16-bit data or 8-bit data in the instruction. For example, move ax comma 0004h. This is a 0004h is a 16-bit data. 16-bit data. This instruction is performed by 004H will be moved to accumulator register. Okay, coming to before the execution of this instruction, A has already stored previous value, previous operation value. That value is A00C. Once this instruction move AX comma 0004H, after the execution of this instruction, the AX accumulator register value can be changed. What what I given to the given an instruction. The value of AX after the execution of this instruction, the value of AX is 0004. Next, another example, in that immediate addressing mode, the source operand is specified either 16-bit data or 8-bit data. First example is 16-bit data. The second instruction example is 8-bit data. Move AL comma 04H. This is the 8-bit data specified in a source operand. The 8-bit data 04 is moved to the lower byte of accumulator register. Before execution, the value of AX is A0, 0C. The AX register is a 16-bit register. That register can be used two 8-bit registers. Can be divided into two 8-bit registers. One is AL. AL means lower order bytes. AH means higher order bytes. After execution of this instruction, the value of AX is equals to AH is equals to 0A, 0A. This is the higher order address by address data. In that instruction, we are using only AL register, then change AL register 0C to 04. This is the immediate addressing. Okay. Next, we go for direct addressing mode. In this mode, the 16-bit offset address or the input output IO address is directly specified in the instruction is called direct addressing. In this mode, the 16-bit offset address or input output IO address 8-bit is directly specified in the instruction is called direct addressing. For example, move AX comma open brackets of 6000H. This is the example of instruction. The data which resides in memory location 6000 and 6001 is moved to AX register. In memory locations, each memory location can store 8 bit of data. 8 bit of data. So, in this instruction, AX is a 16-bit register. That's why 6000 and 6001 location data is moved into AX register. Let us assume 6000 value is 04 and 6001 is 0. So, before the execution, AX has A00C value. After execution of this instruction, AX is equals to 01 higher order 6001 location low location data and after higher lower order byte 6000H. Therefore, AX is equals to 0104H. Next, another example in AL comma 80H. In AL comma 80H. This is an 8-bit address location. So only 8-bit data. In that instruction, we are using only 8-bit register. That is AL. So after execution of this instruction, x is equals to 0105 value. This is the example of direct addressing. Next one, we go for register addressing. Register addressing mode. In that addressing mode, both source operand and the destination operands are used as registers. For example, move AX, BX. The data which resides in AX register is moved or are copied to the AX register. Is called register addressing mode. The value of before the execution, the value of AX is A00C. The value of BX is 0902. After execution of this instruction, AX is 0902, BX is equals to 0902. Register addressing mode means the copy of BX value into AX or are moved BX value into AX. This is called the register addressing. This is a 16-bit data example and 8-bit example. 8-bit data example. Add AL comma BL. Add AL comma BL. The data BL register and AL registers are summed up to the up and the result is stored in AL register. First, AH is equals to 0303, BX is equals to 0102. After execution of this instruction, only in that instruction we are using 8-bit registers. Only 8-bit data will be added. In AL register as 03, BL register as 02. 03 plus 02, 05. 05. After execution of this instruction, AL, AH remains same. AL is equals to addition of AL and BL is equals to 05. There is no change in BX register. Next one, register indirect addressing. This addressing this addressing mode, the address of memory location which contains the data is specified by the offset register. Is specified by the offset register. Is called register indirect addressing. Move AX comma BX is the example of register indirect addressing mode instruction. Assume the BX register has the value of 4000H. Now this 4000H is considered as offset address or our memory location. Then the data is 4000 and 4001 are moved to AX register. The value of AX is before the execution of this instruction, the value of AX is A00C BX 4000. Therefore, Bx is equals to the value of Bx is equals to, let us assume 4000 is equals to 04, 4001 is equals to 06. After execution of this instruction, the value of Ax is 0604. The which value is stored in Bx register, that is moved to Ax register. The 4000 location 4000 and 4001 location data are stored into AX register. This is an register indirect addressing. Next one, indexed addressing. Indexed addressing mode. The this addressing mode, the address of memory location which contains the data is specified by the indexed registers. Indexed registers means in 8086 microprocessor has two indexed registers, SI and D, source index and destination index. In that source operand is specified by a indexed register is called indexed addressing. For example, move AX comma open brackets of SI. is equals to source index. Assume SI is pointed to the contents of 4000. The data is 4000 and 4001 are moved to AX register. Like in the previous section, in the previous one. Register indirect addressing. In that addressing mode, we are using base registers or offset registers. In indexed addressing mode, we are using indexed register. Remaining process of the execution is same. Okay. Next one. Next another example. Move DI comma AI. Assume DI is pointed to the content of 6002H. Then the data in the register AX is moved to 6062H and 6003H. Before the execution, AX is equals to A0, 0C, DI is equals to 6002, 6003, some values. After execution of this instruction, 6002 can move to lower order of AX value, that means 0C. Next one 006003, the value of a the value in higher order AX register, higher order bit in AX register, that is stored into 6003H. 6003 has, after execution of this instruction, 6003 is A0. This is the indexed addressing. Indexed address means we are using indexed registers in source for our destination operands. Next one, further example, register relative addressing. Register relative addressing. In this mode, the offset address will be performed by adding 8-bit displacement value or our 16-bit displacement value. Relative means by adding 8-bit data or our 16-bit displacement value to the contents of any one register such as BX, BP, SI, D. BX means base register, BP means base pointer, SI means source index, DI means destination index. Example of this instruction, move AX comma 50H into BX register. BX register. Before the execution of this instruction, the value of AX is equals to A00C. The value of BX is 4000. 4000. Now the address. Now the physical address can be calculated in 8086 microprocessor is offset address into offset address plus displacement value. In that instruction, displacement value is 50. 4000 plus 50, 4050. 4050 location, memory location, the data is 04. 4051 is data is 6. After execution of this instruction, this 4050 and 4050 data will be moved into AX list 0604. Okay, let us understand. Next, we go for base index addressing mode. In this addressing mode, the offset address will be moved by adding the offset address will be moved by adding the contents of base register to the contents of indexed registers. In the previous addressing mode, we add displacement value. In that in that addressing mode, we adding both base address and source address. Remaining execution process are all are equal. Okay. Before the execution, the value of BX is 4000. The value of SI is 2000. Therefore, we adding BX and SI 4000 plus 2002 6002. In that 6002, we stored a data is 04 and 6003 data is 06. These two address locations data is moved into AX list. That's called the base index addressing. Next one, relative based index addressing. This is the combination of This is a combination of relative addressing mode based index addressing. Is called relative based index addressing mode. Based index addressing mode and relative based addressing mode. Relative register relative addressing mode. This is a combination of register relative addressing mode and relative based addressing. Is called relative based index addressing. In this mode, the offset address will be formed by adding the contents of base register BX, the contents of index register DI or SI, and the adding of 8-bit data or 16-bit displacement value. Therefore, move AX comma 50 SI BX. Assume Bx is equals to 4000, Si is equals to 2002, and the displacement value is 50. Therefore, the physical significance is equals to move Ax comma Si plus Bx plus 50. Assume the value of 6052 location is 40 and in 6053 location is 06. After the execution of these two address locations value into AX list. Okay. Next one, inter-segment and intra-segment addressing modes. In generally, the memory locations in 8086 microprocessor is formed by two addresses. One is segment address and offset or base address. The offset address will be specified in the instruction. However, the segment address will be calculated by the processor based on the nature of the instruction. Based on the nature of the instruction. For any instruction, if the source location and the destination location lies in the same segment, it is inter-segment addressing mode. For any instruction, if the source location and the destination location lies in the same segment, it is inter-segment addressing mode. Inter-segment addressing mode means source location and destination location lies in same segment. Is called inter-segment addressing mode. If the source location and the destination locations lies in different segments, it is called inter-segment addressing mode. Intra-segment addressing mode, inter-segment addressing mode. Intra means same segment, inter means different segments. Source and destination locations are stored in different locations is called inter-segment. Intra means source location and destination location lies in same segment is called intra-segment addressing mode. These two addressing modes further divided into intra-segment direct addressing mode and indirect addressing mode, intra-segment direct addressing mode and indirect addressing mode. First one, inter-segment addressing mode. Inter-segment direct addressing mode. If addresses to which the control is to be transferred appears directly in the instruction as a displacement value, it is an intra-segment direct addressing. Intra-segment direct addressing. Example: jump short label. Short label refers to 8-bit signed displacement. Short label refers to 8-bit displacement data. Intersegment indirect addressing mode means if addresses to which the control is to be transferred, the control is used to transfer is specified through any content of the register. It is intra-segment indirect addressing. For example, jump BX. Jump to the effective address specified by the BX register is called intra-segment indirect addressing. Intra-segment indirect addressing. Next, inter-segment direct addressing mode. If the segment address to which the control is to be transferred and location in the segment appears directly in the instruction. It is inter-segment in direct addressing. For example, jump 2000 H to 3000 H. The address locations are specified directly. It's called direct addressing. The addresses are represented indirectly by using BX register, base registers, or are offset registers, or are source or destination registers. Is called indirect addressing. Jump 2000 into 3000. Second example, intra in segment indirect addressing mode. Jump 2000 is equals to indirect. These are the addressing modes of 8086 microprocessor. Okay, thank you. If you need doubt, please ask me. Okay, these are very useful for writing the assembly programs in 8086 microprocessor. And also we are learning practically in MPMC lab section also. Okay, in MPMC lab section we are doing different programs in 8086 assembly. Okay, if you need doubt, we can clarify in laboratory section and also in classroom. Okay, uh, thank you.